Good day everyone. The topic for the day is materials, and we will be seeing about what material is and what are all the different properties of material, and the major material which is playing around the globe is composite material. We'll see what material is. Okay, so the material is of it completely from the like the material is majorly composed of different atoms which is bonded, single bonded or double bonded. Okay, the large group of atoms together which is agglomerated is called as material. Starting, for example, if we are going to start our day, we are going to starting our day with an alarm clock. That alarm clock is different, it has a different material. Each family or each household has a different types of alarm clocks or clocks. Okay, so it is of polymer or plastic or even stainless steel. Okay, starting from the alarm clock which we are seeing in the morning till the end of the day, so we are completely looking into and using a different types of material with different other properties. These materials are majorly classified into two types. One is which is naturally available, that is for example wood and other wood and other mineral core, and those things are naturally available. And the synthesized one which is artificially or man-made one. Okay, so these materials, as an engineer, we can classify the materials into a engineering material. There are two different, like two basic and two major differences: metallic and non-metallic nature material. So the metallic material which is differentiated with the help of ferrous and non-ferrous nature. So the ferrous nature is iron content. Okay, so whichever the material has an iron content and varying with the iron content is said to be a ferrous material, and the non-ferrous material is said to be a the non-ferrous content materials are said to be as type of a metallic material. Then it is of non-metallic material, which is of ceramic and polymers. With the polymers in the layman's language, it is said to be a plastics. Okay, in our day-to-day, we are using PVC pipes, that is polyvinyl chloride pipes, and like PE bottles, like PETG bottles, and other bottles which we are using day to day life. Those are called as polymers. And now we will be seeing about the what is the properties of material. We have seen different materials and how these materials are categorized. The majorly these materials are categorized based on its property. So when we are focusing on to a material, the five different properties plays a major role. One is mechanical property, electrical property, thermal property, magnetic property, and optical property. Mechanical property, by the name itself, we can able to figure out all the mechanical forces or pushing force, pulling force, twisting force, bending force. Those will be categorized, and the how the material is behaving to that forces are said to be as mechanical property. And the conducting nature and the insulating nature of a electricity of a material, that defines the electrical property of a material. Then the absorption of heat, that defines the thermal property. Then attracting towards the magnet, that defines a magnetic property. And whether how it is behaving with the help of light, when it is exposed, whether it is refracting or deflecting or reflecting, those things, the lights, those things are called as the optical property. Okay, so these properties are varying from each material. So every materials are of basic, every materials are depending on the property of a material. Okay, and it is also classified into different categories by these types. So these are the major five types. One is of homogeneous, non-homogeneous, isotropic, anisotropic, and orthotropic, and how these properties are behaving throughout the body of the material. Okay, so when we are focused on orthotropic in nature, so the property will be different in three mutually perpendicular direction. We all know three mutually perpendicular direction is x, y, and z. So these properties are different in each other. So this is how actually the materials will be classified based on the properties and its nature in the different direction. So now we'll see what is composite material and how it is playing a major role. The composite material started to invade into aerospace. Almost the Boeing and Airbus have started to use composite material in a wide range. because of its different advantages. Now we'll see what is composite material it's all about. So the composite material is majorly composed of two or more constituents. So those two constituents are matrix and reinforcement. We will be seeing in the later slides what matrix and reinforcement is. Then when we are looking into, if we are going to fabricate on a composite material, and when we are looking into our naked eyes, we can able to figure out it is of single material. So it does not contain so many things. So we can, with the help of our naked eye, we can't able to figure out anything. So that is said to be as homogeneous nature. So as a human, we can able to see that this is of a same material and it is one particular material. But when we are seeing through the microscopic lens or through a machine eyes, we can able to figure out that this composite material is of heterogeneous in nature. Okay, so what is the significant difference between each constituent and how it is different, whether it is based on its shape, chemical composition, insoluble nature. So it should not soluble with each other. If what it means is, when it is started to soluble with each other, it started to react and it forms an another material. So there will be a chemical reaction, there will be advantage and disadvantages. So this should not, like two material that should not constant like that should not chemically reacted or insoluble, basically it should be insoluble nature, and it also should be of chemical inertness. It does not react, it should not react to any of the chemical. So as in the previous slide I have told, it's the composite material is of two types. One is matrix and reinforcement. Now we see what is the role of a matrix in a composite material and what is the reinforcement role in the composite. Like we all as a, like Indians, we all know what is the role of sugar syrup and bundi in laddu. Okay, what is the major role, like major role of sugar syrup plus bundi in a laddu? Okay, so for making a laddu we have to create bundi, okay, which gives a major tasty taste of a laddu. And sugar syrup, it is like a adding content or holding bundi and adding a like a sweetness to the bundi that creates the laddu. So we have to have a sugar syrup and bundi together to form a laddu. So the same principle here in the composite material also. So the sugar syrup, the matrix plays the role of sugar syrup. As a layman, I can, like, you can just exactly we can't tell, but you can just able to remember how reinforcement and matrix are different. So what is the role of sugar syrup in laddu? It should hold the bundis together. The same principle here also in matrix. It will bind the reinforcement together. And what is the sugar syrup? It will give a sweetness throughout the laddu. So the same thing. Here it is stress. Okay. So the stress is completely transferred or equally distributed to the fiber. And then it also acts as a protection layer of the reinforcement of the composite material. And what is the role of reinforcement? It should be of high strength. When we compare sugar syrup and the bundi, the sugar syrup has a like complete has a less strength compared to bundi. So here you can figure it out. So the role of reinforcement is to have a high strength, stiffness, and have a mechanical improved mechanical property. Every material, you name it, it should have some good mechanical property to serve as a material to a common applications. So here the reinforcement plays a major role in improving the mechanical property. Okay, so with the help of this laddu example, you can able to like at least categorize, at least classify how like matrix plays a role in composite and how reinforcement plays a role. So now we'll see about history of composite. So again, the composite is classified into natural composite and man-made composite. So as every even in every fields, always God has a major role in the invention. Okay, even in aircraft, the Wright brothers, when they started to create their own flight, they have an inspiration towards the bird. So the same principle here in composite also. So before a man-made started to create, God has already created a composite in the nature. So what it is? We are seeing day-to-day life a wood. Wood is actually made of lignin and cellulose. So then bone. Bone is made up of collagen and HAP mineral crystal. So these act as a matrix and reinforcement. So these are the two different or the major natural composite which is available. And what is the major man-made composite in the starting stage? In the ancient days, we have created, nowadays we have different bricks for building, for building purpose, building construction. So the bricks are made up of red mud or hollow block, and the other block system has been invented, interlock block, and there are so many has been invented nowadays. But in ancient days, we have a brick which is made up of mud and straw. Okay, then concrete which is made up of cement and gravel. For a simple understanding, you can able to figure out this is how the natural composites and man-made composites are varying. So the mud plays a major role of matrix and straw plays a major role of reinforcement. Here in the cement and gravel also. Then we could able to figure it out how the composites are differing from the BC to the current trend. So how the composite plays a role, how polymers, metals and ceramic plays a role throughout the history of composite. Okay, so how it is different, we'll see in this. Okay. So what are all the major advantages and disadvantages of composite? So the major advantage and disadvantages are, it has the major advantages as it has a reduced weight and high strength. Then high stiffness, wear and corrosion resistant. Like reduced weight and strength is that for aerospace application, we have to create a material which has a less weight, but it should be having a more strength, because it should hold the weight of a cargo or payload which is traveling throughout the its journey. So the composite plays a very major role, and it has a widespread of application in aerospace industry. um, then it should have a wear and corrosion resistant. It should not get friction, like it should not be like tear or wear after so many set of usage. And there are huge number of disadvantages also, because it is, the fabric is very hard for tooling, and there are so many hidden defects which is we could not able to figure it out. So but we have a quite lot of technology which has been developed nowadays. When we focusing on the non-destructive testing, NDT testing, there is huge so we can, without destroying the particular material, we could able to figure out what is the defect, and we need a special tools or process and to be identified. And there are the some of the raw materials or even like synthetic fibers, example Kevlar, carbon and other fibers, glass fibers, those fibers are really high cost in nature. Then even we don't know whether this composite material we are continuously exposing into the environment where we are fabricating the composite material, whether it affects the human health. So there are different other disadvantages also there. So in when we focus on the application part, it's starting from the automobile, aeroplane, helmet, sports and other different marine application, building application. The composite has a very major role in the different application in the different field. So what are all the major composites which is available? That are the different types. We'll see now. Okay, the polymer composite materials available, ceramic and metallic composite materials are available. So in the previous slides, we have seen what actually composites are. Composites are made up of matrix and reinforcement. Now we'll see what matrix plays a role. So the matrix is again classified into polymer matrix, metal matrix, ceramic matrix and carbon or graphite matrix. So the polymer matrix is again classified into thermosetting and thermoplastic. Okay, so this polymer matrix plays a very major role in the household application till the automobile and the aerospace application. So there are two different types. One is when we focusing in polymer matrix, there are two different one. One is thermoplastic and thermosetting. So the thermoplastic materials are like, for example, you can take a vessel in your house to store water. So that has a that those metals like those vessels are thermoplastic in nature. It can be softened upon heating or given pressure. It can be reformed into other different shapes, and but thermoset we can't do it. Thermoplastic, some plastic are repairable and we can process easily, and there are so many other resistance to it is very good resistant to the solvent, and even it has a very high processing temperature. But when we focus on the thermosetting, it is like not that much like flexible like thermoplastic, but it is of high good strength and it requires a long curing cycle and lower processing temperature. So these are the some of the difference between thermoplastic and thermosetting. So the different types of thermoplastics are polypropylene, propylene vinyl chloride, PVC, nylon, polycarbonate, polysulfone. When we focus on thermosetting, it is polyester, epoxy, and polyimide. So what is the advantage and disadvantages? Like advantages of thermoplastic and thermosets. So these are the few advantages of it. So what is metal matrix, and what is metal matrix is aluminum, titanium, copper. These are the three different metals which are used nowadays. So this has a advantage as well as disadvantages to it. Advantages are high strength and toughness, and disadvantages is corrosive and heavier. Okay, then ceramics are carbon, silicon carbide, silicon nitrate. So those are the ceramic material. So these ceramic materials are majorly used for the higher temperature materials, which is of it can withstand till 2000 degrees Celsius and high elastic modulus. When it is the disadvantages of is brittle in nature. When we focus like for example, we can take a tiles. That tiles are very brittle in nature. Once you like drop down, it has a very less impact strength. It will broken into different pieces. So these are the major difference of polymer, major difference of the matrix. So the temperature scale applies here. The from a low temperature to some extent we can use metal polymer matrix and the metal matrix. Then it has a very high temperature gradient is ceramic matrix. So now we'll focus on the reinforcement. Reinforcement is based on the is classified based on its size, fiber size of the composite, like size of the reinforcement. One is fiber, whisker, flakes, and particulates. So the fiber, sorry. So when we focus on fiber, actually fiber is of the length to dia ratio will be very large. It has a huge length and the very micron level diameters is available. This thing same applies to whisker, flakes, and particulate also. And the again the fiber is classified into two categories like natural fibers and advanced fibers. Natural fibers or which is we can able to extract it from the nature. Animal fiber, plant fiber, or mineral fiber. Animal fibers or silk, wool, those things are comes under the categories of animal which we are able to extract from the animal. So now we'll see about the different how the fibers are classified based on the availability or the source of the fiber. It is of natural fibers and advanced fiber or synthetic fiber. So the natural fibers majorly are animal fiber, plant, and mineral. Okay, so these are available in the day-to-day environment. So the animal fiber majorly goes to whatever the materials which we are extracting from the animal body, that is called animal fiber, and basically we can able to figure it out like silk, wool, camel hair, those are majorly used. Plant fibers are like we are going to take the plant fiber from different parts of the plant, whether it is um, like a bast portion, leafy portion, or stem portion. Those things comes under the category of plant or vegetable fiber. Then it is of mineral. So it is taken from the core of the uh, core earth ground. So, okay, so those are classified as the mineral fiber. So again the mineral, like as we see in the previous slide, the fibers are classified or like reinforcements are classified into 5 different types based on its shape and structure. So one is continuous fiber and short fiber, whisker, flakes, and particulate. Okay, if the fiber is of very long and if it is not unbroken before it's been used, that is said to be as a continuous fiber. And when the fiber is finally chopped into a different small pieces, it's said to be a short fibers. And whisker fibers are that it has the cross sectional of the fiber will be of polygonal shape. Then flax fiber, it has a 2D geometry, and the strength of the flax fiber, it's comparatively compared to the fiber, it has a good properties. And then particulate, the size of the particulate, it's very a few micron level. Okay, and even the particles plays a, like wherever we are using the particulate, it has a different properties and strength. If we focus on carbon particles or aluminum particles, it also enhances the mechanical property and the different special properties of the composites. Okay, so the fibers, okay, so these are the different types of reinforcement. So this, how this reinforcement, that is that fibers are oriented in the composite, and how these composites are further classified. So this, like when we are going to use a continuous fiber or discontinuous fiber. If we are going to use continuous fiber, which is a lengthy fiber or short fiber, that we can able to create in the two different type. One is unidirectional and other is oven type. Unidirectional is like you have like most of the researchers will be using in the single layer. Then oven type is like we can oven it the fiber into bidirectional, and even the three-dimensional like woven fiber mats are available. And discontinuous fiber, obviously it is of particulate, whisker or flakes. It has been randomly oriented, or like in the preferred orientation which actually they wanted. So these are the sum of the fiber orientation composites. So this is how the composites are, the composite material, which is actually classified into two different constituents. One is matrix and reinforcement. We have seen the types of matrix and the type of reinforcement, and how this reinforcement is actually oriented into the composite. As a brief introduction we have seen. We'll see further in detailed in the other videos. So thank you for watching.